So let's start this video with situation D. So situation D here says we have 0 velocity and 0 acceleration. Well, 0 velocity and 0 acceleration, basically that just means we're at rest. Anytime we're not moving, we're at rest. So on a position time graph, anytime you're at rest on a position time graph, that just looks something like this. So come up here, you can just draw a straight line anywhere you want through your position time graph to represent that you're at rest, right? Because when you're at rest, your position just stays constant with time. Okay, so if we're at rest, that means our velocity is 0. Our velocity is 0. I'm going to come over here, and I'm going to do a nice bold line through 0 velocity. It's a nice bold line through 0 velocity. Okay, so that means right here I'm at rest. 0 velocity is also the same thing as 0 acceleration. Anytime I'm at rest, I'm not accelerating. So my acceleration is also 0. So I'm doing a nice bold line right through 0 here for acceleration. And that's how situation D looks. Okay. So let's move on now to situation E. Okay. Situation E, and remember, my elevator is moving upward in every instance shown. So I'm just going to draw a straight line, a nice straight arrow pointed up to represent 0 velocity. So for situation E, I have I have a positive velocity, which is 0. I do a arrow to represent that I'm getting ready to move in the positive direction, right? Starting from 0 and getting ready to move in the positive direction. So a positive velocity and a positive acceleration, meaning that I'm speeding up. So positive velocity, positive acceleration, speeding up. How does that look like on a position time graph? So on a position time graph, we're going uphill and we're becoming steeper with time. For a velocity time graph, that means I'm on the positive end and I'm getting further away from 0. So my velocity time graph looks like this. Now, how do I represent my instantaneous velocity at a point? So if you come over here, my instantaneous velocity at a point was 0. So in order to denote that on my velocity time graph, that looks something like this. So I'm going to put a point there right at 0 to represent that. So guys, what's going on here? In the real world, what this point right here represents, right at that moment that I'm in the elevator and I'm at rest, and at some point the elevator starts speeding up, going up. So this point right here represents that instantaneous moment in time, just as I'm about to go up. So I'm accelerating upward from a 0 velocity. So my instantaneous velocity at that point is 0. Then I start speeding up, going up. In other words, speeding up in the positive direction. And okay, if you come over here, I see that my acceleration here is positive 2 meters per second squared. So I'm going to come over here and I'm going to do a straight line through positive 2 meters per second squared. Okay, and those are my graphs for situation E. Lastly, let's look at situation F here. So once again, I'm gonna draw a positive velocity to show that I was moving upward in every instance shown. That was my inertia. My inertia was upward. So anytime I have a positive velocity, and here for F, I have a negative acceleration. So if you notice here, that means here, this means I'm slowing down while moving in the positive direction. So on our graphs here, that looks like this on a position time graph. Slowing down in the positive direction means I'm going uphill, but now I'm becoming flatter with time, right? Because anytime you're becoming flatter with time, that means you're slowing down. Velocity time graph, we're on the positive end and we're slowing down, so we're approaching 0. And my instantaneous moment represents the point here just as I'm reaching the top of the elevator shaft and I'm coming to a stop. So my instantaneous velocity here would be 0 at that point. So I'm at the top of the elevator shaft and I'm slowing down, and eventually my velocity hits 0. And look at my acceleration here. My acceleration is negative 9.8 meters per second squared. So what that tells me here is that for a brief moment, I'm in free fall because my acceleration here is negative 9.8. So I'm going to come over here and I'm going to draw a straight line through negative 9.8 meters per second squared. So basically, guys, in the real world, what this represents, you can think of this like this. You're going up an elevator shaft and you start slowing down just as you're coming to a stop. And right at that moment, just as you're coming to a stop, pretend for a second that right at that moment, your feet, they aren't in contact with anything, just as you're coming to a stop. So for the brief moment of time, you will be weightless because you're not in contact with anything, and the only force acting on you is gravity. So at that brief moment, your acceleration is equivalent to gravity, which is 9.8 meters per second squared. And again, so we're assuming a brief moment of time. So basically right here, this time interval right here, this time interval represents like a few milliseconds. For a few milliseconds, you're experiencing weightlessness. And you can kind of think of the Superman ride. For any of you guys that have ever been on the Superman ride, as you're approaching this top and you're slowing down, just as you're reaching the very top of your trajectory of your path, for a brief moment of time on the Superman ride, you're not in contact with anything and you experience like a few milliseconds of weightlessness. And so that's kind of what's going on here. All right, so that's our grasp of situation F. If you guys have any questions, please do not hesitate to come see me.